Okay, so let's start our class today. So first lesson we'll see examples on astable multivibrator using 555 timer. So let's see a couple of examples on how to design astable multivibrator or using 555 timer as astable mode. So as we have discussed last time, astable multivibrator means the output turns on and off of this 555 timer without applying external trigger or threshold. The output goes high and low with specific period of time T on and T off. So let's see examples. So when we start, so 555 timer. Astable multivibrator. Multivibrator. Okay, so the circuit diagram, as you know, we need a 555 timer IC. This is our 555 timer. Okay, so as you know, pin number 8 is VCC. Pin number 4 also connected to VCC, the reset pin, goes to the DC power supply VCC. So let's apply 12 volts here. Okay, pin number 1 is what? Pin number 1 is connected to ground. Pin number 5, we are not using pin number 5. So as we have discussed last time, to minimize noise, it's better to connect pin number 5 to ground through a capacitor value 0.01 microfarad. Okay, because we are not using input pin number 5 called control voltage. Pin number 1 is ground. Our pin number 3 is pin number 3 is what? The output. Here is our output. So in astable multivibrator, the output turns on means high voltage, and off, on, off, and so on. Okay, are we applying external trigger or threshold? No. By itself, the circuit turns on or off. So this time period where the output is on, let's say it is T on, or you can say high voltage. Okay, so in this time period, the output T, how long the output is low voltage, let's say it is T off. Okay, you can say T high, T low, or T on, T off. So here we have pin number 7, discharge pin. pin number 6, and pin number 2. As you know, in 555 timer IC, this is our 555 timer IC. Pin number 2 and 6 are inputs, threshold and trigger input. So for Astable multivibrator design, they are connected together, shorted, and connected to a capacitor. Okay, here we have capacitor C. Okay, so this is it. Capacitor value C. So the voltage across the capacitor VC is applied to what? Applied to pin number 6 threshold input and pin number 2 what we call it trigger input. Then this capacitor is charged through two resistors. One resistor RB, and this resistor let's call RA, and connected to our battery here. So this resistor is RA and this resistor is RB. Okay. Now what remains? Pin number 7, which is called discharge pin. So pin number 7 is connected between the two resistors here. This is very simple circuit with what we call it 555 timer Astable multivibrator. So in this case, when you give the battery, the output will be this square waveform, on and off, and so on. Okay, now what will be the on period? How much this output turns on, this time period, T on, is equal to the formula I'm talking about, 0.693, the summation of the two resistors, RA plus RB times C. This is the time period where the output is on. Okay, so if you connect here in the output light emitting diode, okay, or a light in the traffic light, for example, in the traffic light in the road. So if this is green or red light, how much time it is on? T on is equal to 0.693 RA plus RB times C. What is RA? Resistor here. What's RB? Resistor here, and C is the capacitor. Now, why this RA plus RB? Now, when you connect this battery, the capacitor starts to charge. As I have discussed, capacitor is a charge storage device, right? Charge storage device, just like a water container. So a water container, initially this capacitor, which is store charges, capacitor is charge storage device. So initially it was 0 volt, no charge. Then when you connect a battery through this capacitor, when you connect a battery, ground here, as you can see here, ground. So now charge starts to develop, store in the capacitor. Okay, charge stores in the capacitor. How much is now the capacitor is charging? What will be the voltage? The voltage across the capacitor. If you plot the voltage across the capacitor, VC, this is VC. Initially it was 0, then starts to increase. What type of this one? This is exponential. The capacitor charges exponentially. E raised to T divided by R times C. Resistor and capacitor determines the time for charging. Okay, how fast the capacitor charges and discharges depends on the value of the resistor and the capacitor. So in astable multivibrator, when capacitor charges, output is on. So look here, in this on period, capacitor charges. In the off period, capacitor discharges. Okay, so let me show you here. When you see this, when output is on period, what will happen to the capacitor? Capacitor charges. We have discussed this last time. Okay, capacitor charges. When output becomes low, capacitor discharges. Capacitor discharges. So here, this diagram, as you can see, capacitor charges through which resistors? Capacitor charges from the battery, the charge comes here and go to the capacitor and stores in the capacitor. So which resistors? Two resistors in series, RA plus RB. That's why you see the equation. How much is T on? 0.693, which is a constant. RA plus RB times C. That is the on period. How much will be off period of the astable multivibrator? This off. How much time this output becomes off is given by 0.693. Again, a constant, 0.693. In this case, only RB times C. I'll show you this using examples. So, why only RB in this case? Look here, in the on period, so when you see here, in this equation, where the output T high is 0.693 R1 plus R2 times C. R1 is here, 10 kilo ohm. We call this RA in our case, right? We call it RA. R2 means RB in our case. How much? 20 kilo ohm. This is a capacitor C, 680 nanofarad capacitor, right? So as you can see here, the output becomes on and off. So how much time the output is on? Given by this equation. T high is equal to 0.693. Okay. T on, as from this equation, 0.693 RA plus RB times C. RA and RB are here. C is here. So the time of the period for on and off or high and low depends on what? Depends on how much resistor and capacitor we put here. Depends on these resistors and capacitor, we can control the on and off period of this 555 timer, astable multivibrator. So T on is equal to what? 0.693, which is I said constant, times RA plus RB times C. So let's see example here. So when RA, we connect how much resistor? 10 kilo ohm. Okay, 10K resistor. RB, we connect 20 kilo ohm resistor. And the capacitor, we connect 680 nanofarad. Okay, so as you know, 555 timer, we bring our timer here, pin number 8 and 4 connected to what? Connected to VCC, our DC. Okay, then we need how many resistors? 2 resistors, RA first, then RB in series. All these are in series, connected together and to ground. So this is how much? Our 10K. Here is 20K. Here capacitor 680 nanofarad capacitor. So how we connect 2 and 6? Pin number 6 and 2 shorted together, connected together, and connect to the capacitor. Pin number 7, discharge 1, connected to between the 2 resistors. So this is RA, RB, and C. How about pin number 1? Pin number 1 is ground. Pin number 5 is also ground through a capacitor. What remains? Our output, pin number 3. Here you get your output. What's the output of astable multivibrator? It changes from high to low. So this is what? T high. This is T low. Okay. So the question is, how much is T high in this case? So what is T high from our formula? T high is equal to 0.693 times the summation of the 2 resistors, RA plus RB, because they are connected in series, times the capacitor we use C. Okay. So 0.693. How much is RA? RA is 10 kilo ohm. RB is 20 kilo ohm. Okay. Kilo means 10 raised to 3 times capacitor 680 nanofarad. 680 nano means 10 raised to -9. So if you calculate this, we get how much? We get 14.1 millisecond. So this output is on only for 14.1 milliseconds. For this time period, this timer output is on. Okay, you see, it's very simple design. Now, how much period, how much time it remains off, which is T low. T low is equal to 0.693. It's a constant, but to calculate T low, we use only RB times C. Now, if you see this formula, T high, we use both resistors RA and RB because the capacitor charges through these resistors. That's both resistors. But when the capacitor discharges, look here, in the ohm period capacitor charge, When output is off, capacitor is discharged. Which pin is discharge the capacitor? Pin number 7. So when this capacitor charges, it charges through RA and RB and charge stores. Now when this transistor in the pin number 7 is on, capacitor discharges to the pin number 7. So when it discharges, only this resistors comes to picture. When it's charged, both resistors comes to picture. Okay, so you have to know the charging path and discharging path. So in the discharging path, we have only RB. Okay, so how much T low? 0.693. How much is RB? 20 kilo ohm resistor. Kilo ohm means 10 raised to the power of 3. And capacitor, how much capacitor we use? 680 nanofarad capacitors. Nano means 10 raised to minus 9. So if you calculate this, off period is how much? 9.6 milliseconds. Let's check this my calculations. So this is off. This astable multivibrator used in so many applications. It generates a square waveform. The output can be on and off. On period, you can design it by this equation here. What is T on? 0.693 RA plus RB times C. But if you change C or RA and RB, you can adjust what? How much time it is on. You can control how much time it is off. You can change it by changing what? By changing RB or C. If you change RB or C, the off period also you can adjust it. Okay, but to revise what we have discussed so far, 555 timer can be used in astable multivibrator mode. Before that, we have discussed bistable, right? So when you see bistable mode, in this case, it's a bistable circuit. To change this output, this is pin number 3, right? To change it on or off, we have to apply external set and reset inputs. Pin number 6 and pin number 2 inputs, right? It's bistable. It does not change state unless you give trigger or threshold. That's bistable. The opposite to that is astable. In astable mode, once you design it, by itself, it becomes on, off, right? It's a multivibrator called astable multivibrator. Okay, so as you can see here, based on now the capacitor, we use this capacitor to control what? To control our inputs. We have discussed this how it works. Let me explain once more because it's very important. So assume this is a 555 timer internally. I want to show you what is internal and external. So let's say this is our 555 timer. So internally we have what? 2 comparators. We have discussed this last time. Comparator C1 and comparator C2. This is internally. Okay. So this is comparator C1. The non-inverting terminal, inverting. This is non-inverting. This is inverting. So this comparator C2, comparator C1. Okay, now internally again, we have resistors R1, okay. So comparator C2, positive non-inverting terminal connected here. In this case, the negative is connected here. All these are internal, okay? So this comparator outputs, they go to the flip-flop, we call it RS flip-flop, okay? So this is the set input, this is reset input. This has output Q bar, which is inverted by inverter, goes to output pin number 3. Okay. This is pin number 6. This pin number 2. This is ground, pin number 1. This is pin number 8 and pin number 4. Okay, this is to reset. Now this one capacitor is pin number 7. This is our 555 timer. So let's see. As I said, pin number 8 and 4 are connected to what? Connected to a battery. Let's say 12-volt battery. We connect where? At pin number 4 and pin number 8. Then we bring this battery, okay, connect two resistors in series and one capacitor. Sorry, let's continue here and connect one capacitor here. Okay, so this is C, this is RB, this is RA. Now, pin number 6, which is the positive terminal of the capacitor, comparator 1, and the negative input of comparator C2 connected together to the capacitor VC. This is how it works. How about pin number 7? Pin number 7 comes here and connect between the two resistors. So this is called discharge transistor. All this inside. Okay. Now, this 12 volt, as you know, is divided 2/3 here. Here we have 2/3 of VCC. So 2/3 of 12 volt is 8 volt here. 1/3 of VCC here. Always, we have discussed this last time. So 1/3 of 12 is 4 volt. How about the other input of the comparator, which comes from where? Which comes from the capacitor, VC. Capacitor VC comes at pin number 6. Here is what? VC. Here is also what? VC. Capacitor voltage VC at pin number 2 and at pin number 6, as you can see here, comes from the outside capacitor. How much voltage is stored here? Comes to pin number 6 and pin number 2. And it compares with what? It compares with 2/3 of VCC. These 3 series resistors divide the VCC into 2/3 and 1/3. We have discussed last time. So this is 8 volt, 4 volt constant. Now VC is the other input. Voltage across the capacitor, this one. we bring it to the two comparators. So let's say how much voltage stored in the capacitor. Okay, let's say 9 volts. What will happen to the outputs? Let's see. If the capacitor stores 9 volts, pin number 2, here is pin number 2, how much? VC is how much? 9 volts, comes from the capacitor. Again here, pin number 6, also connected to VCC, this one. So VC is how much? VC is 9 volts. Okay, now what is the output of comparator C1? Which one is larger, positive or negative? Positive is 9, negative is 8, positive 1. Positive is larger, so the output is 1. How about C2? Positive terminal is 4 volt, negative terminal is 9 volt. Which one is larger? The negative terminal, so it will be 0. So R is 1, S is 0. So from our RS flip-flop, if R is 1, S is 0, what will be Q bar? Q bar is 1. Okay, so Q bar is 1. So what will be the output? 1 inverted, output will be 0. 0 state. If this is 1, you see this one goes to which one? The transistor. So this transistor, discharge transistor, when Q bar is 1, now this transistor is what? This transistor is on. When it is on, capacitor, instead of charging, it goes through RB. This one go to ground and it discharges. Capacitor will not continue charging. At some point, when pin number 7 becomes on, it starts to discharge. Okay, this way, the voltage across the capacitor, VC, controls what? Controls our output on and off. It also controls the time period, for how much time the output is on, how much time the output is off.